Hello there. Today's lab is about Archimedes, Archimedes principle. Okay. So according to Archimedes, like any object that is partially or fully submerged in a fluid experiences an upwardly force known as buoyant force. Okay. So that means like if you insert a certain wooden block in water, then like for instance, then the wood is floating because there is an upwardly force that keeps it up, and known as buoyant force. Okay, so then today what we're trying to today in today's experiment, what we're trying to prove is like if that Archimedes principle is valid or not. So the way we are going to proceed with this experiment is the following. So there are two items that we should know about Archimedes. So this buoyant force is the same as the weight of the displaced fluid. Okay. So that means the amount of the weight of the water that is displaced by this wooden object is the same as the buoyant force that it experiences. That means every time when you submerge yourself fully in water, then the amount of water that you displace is the same as the amount of buoyant force that you experience. Okay, so that means then your buoyant force is equivalent to a buoyant force that you will experience. It will be equivalent to like the mass of the fluid multiplied by gravity, right? So the mass of the fluid, mass of fluid multiplied by gravity. But at the same time, mass will sit like in our lecture. The mass of any object can also be determined as the density of the object multiplied by the volume. Okay. So in this particular experiment, what we're trying to do is we are going to insert a certain metallic object in a liquid, and then we are going to displace the amount of water, and then we are going to collect that displaced water, and then we are going to measure its volume. Then once you measure its volume, what you will do is like you will multiply that by the density of the fluid. Since we are going to use water, the density of water is 1000 kilogram meter per meter cubed. Okay, then the amount of water that is displaced and that has to be inserted in meter cubed, you multiply that by 9.8 meters per second square, then that will just literally give you what the buoyant force of the object is. This is one way of finding the buoyant force. The other way of finding the buoyant force in this experiment is by just simply measuring the weight. What you will do is like first we are going to have that small metal. It can be copper, tin, or zinc. Then you take that and then you weigh it. So you weigh that object. Then the second object, this is like in air. The second step, what you will do is like you are going to take that object, okay, and then there is water, and then you will hang the object when it's fully submerged. You will hang it with a hook, and you weigh it, like then you find a weight that measures the weight of this object while it's still fully submerged. Then weight in fluid or in liquid, in water in our case. Then according to Archimedes' principle, that buoyant force can also be calculated as the weight of the object in air minus the weight of the object while it's submerged in fluid. So that means we are going to find two buoyant forces. One buoyant force using this star equation. The other buoyant force, we're going to use this double star equation. Once we found those two buoyant forces, we are going to go ahead and then we'll find the percent difference between the two. So buoyant force 1 minus, that means buoyant force following method 1 minus buoyant force 2 divided by the average of the 2. Multiply that by 100, then that is going to be the experiment. Okay, so here is your data table. That's what it will look like. Then we're going to give you like the volume of water when it's like just in a certain cylinder. You pour water and then you have 62 milliliters of water. When you put in like a copper cylindrical metal, that's a small piece of metal, into the water, the level of the water raised to 69 milliliters. Then if you take the difference between those two, it's going to give you this value, which is the volume of the object. Then you need to convert this milliliter to its equivalent meter cubed by dividing it like by a million, because for every milliliter you have 1/1,000,000 of meter cubed. Once you found that, what you will do is, as you can see here in the Excel equation, you need to multiply the volume multiplied by the density of water, which is given right here, multiplied by 9.8, which is the gravity. Then that's going to give you like the buoyant force. In the second method, as we mentioned it, you weigh the mass of that little object when it's in air. This is the mass. To find its weight, what do? Mass times gravity, as you can see it here in this Excel equation. Then that's going to excuse me, that will give you like the weight. And then you do the same kind of approach for the apparent mass. Apparent mass means when the object is fully submerged. Why do we call it apparent? Because it's not a real kind of weight, because you feel lighter when you are in water, right? The same thing would feel that small metal. Its weight will be smaller than what it's really in reality. And that value is given as 0.0552. To find its apparent weight, what you will do is like this given weight in water multiplied by 9.8, you can see it in this Excel, then you find that. Okay, so you find its weight. Then the buoyant force will be the difference between the weight in air and the apparent weight. Then you find the percent difference here. The percent difference has to be calculated between the two values, between this buoyant force minus the other buoyant force that you calculated in the first table, right? And then you divide that by the average of the two. The average of the 2.5 into this guy plus this guy, then you multiply that by 100, then approximately this is the percent difference. You proceed with the rest of them. That's it for today.